ANSYS Simulation, Lecture 5, Part 2. The effect of constraints on the natural frequencies of a structure. Open an assembly file. Computer, C drive, program files, SolidWorks Corporation, SolidWorks, simulation, examples, and use large icon and filter with assembly. And we can find the shaft assembly. Open it and save it on desktop so we don't mess up the original file. Now make sure that ANSYS is loaded. The program or the software should be loaded, and then we'll enter ANSYS workbench. And the first interface of ANSYS workbench will be schematic project schematic. And this is the organized interface for ANSYS. And I'll drag model analysis and drop on geometry. And I need to add a material to it. So I choose data source, general material, and I'll add copper alloy to it. But actually, this is not what I really need. I need bearing bronze. But for now, I'll choose copper alloy and go back to project and enter ANSYS mechanical by editing model. In this problem, we'll talk about the effect of constraint on the natural frequency of a structure. So, first of all, we need to define the material for each parts. So, for the shaft, we'll make it structural steel, and for the bearings, I'll choose copper alloys. So, I have defined materials for each part, and I finished with the first step geometry and second step material. And for the third step, I'll simply update the mesh. And for step 4, I'll zoom in. I'll zoom in the geometry. And then I'll choose fixed support and select the surfaces 1, 2, 3, 4. The 4 surfaces are fixed, and I'm not going to place any load because it is blanked out. And before I run this procedure, I need to determine how many frequencies that I will let it calculate. So I leave it as 6, and I'll solve for the procedure. And now I've got the natural frequency. The lowest natural frequency will be 1319.8. Now I'll loosen the support. And by loosening the support, I have made the rigidity or stiffness of the structure lower. So now I'll edit to only fix these 2 faces and leave these 2 holes unsupported. So I have actually loosened the fixture of the structure, and actually the stiffness of the structure is decreased. So I run the solution again. Now the lowest frequency dropped from 1319.8 to 464.59. So there's a significant change or drop in natural frequency. And the reason is that by loosening the fixtures, we have actually decreased the rigidity or stiffness of the structure. And by decreasing the stiffness of the structure, the natural frequency of the structure also decreases. So this is how, in general, machines, or for example in a car, if you drive an old car, you hear the clattering sounds, in a lot of noise in the car. And this is because when a car gets old, the bolts got loosened and the rigidity or stiffness of the structure decreases, and therefore the natural frequency drops, and therefore you can hear lower frequency sounds. And to fix it, theoretically at least, you can fix all the fixtures back and the noise will be gone. So in this example, we talk about loosening of fixtures will decrease the rigidity or stiffness of the structure, thereby decrease the natural frequency of the structure.